Hi and welcome. So this time around we have an interesting project. I've been given these laminations of different sizes and shapes, and you can see, hopefully there, you can see inside the bag there. And this project's to make a fixture that'll hold a stack of these laminations very accurately in place so they can be welded. So you'll build up a stack against something like this, and they'll run beads down both sides with a TIG welder, or a laser welder in this case, I believe. I'm not actually sure which one they're going to use. So it's going to be a bit challenging because this diameter will still let the parts rotate around. So I've got to have a stop over here, but then it could fall out this way. So what I've decided on, in the case of this larger one here, they're actually sort of very similar, is I've got these little flat pieces that are going to run along the length. I'm going to remove some material, leave a flat on both sides, and we're going to create these pieces with thumb screws and slots that can slide down over this and overlap by about 50 thousandths each, which is not very much. And I've already made these two pieces here. Here's some footage of me turning the big one. So the next thing I got to do is I got to take this over the mill and turn the flats on this side and the flat on the bottom to get my fixture dimensions here. This one is going to be even more challenging. So there's going to be some little holders along the side that run the whole length of the side here. This would be this way, if you can see that length right there. There's also stops on either side. So I've got to cut some 4/10 inch wide slots on the side, a 1/4 inch deep on one side roughly, and just 50 thousandths deep on the other side. The deeper one on one side is a dead stop, and I'll be using these low profile screws. They're Allen head screws that are low profile, to hold the dead stop on one end where you'll slide all the laminations down against, and there'll be another one on top with a set screw so you can have a little bit of force pushing the whole stack together. And that one is going to be located with a 4/10 of an inch slot that's only maybe 50 thousandths deep, if I remember right, so that it won't rotate, but you can unloosen the thumb screw quickly and rotate it out of the way to get your stack in and out and to load up the next one. Both these parts are going to be the same. This one's kind of small. I'm kind of concerned about this one here, whether that's going to work. I may have to add something to the bottom. We'll just have to see. There's the scale drawing, and once you put the flats on the side, they're actually only going to intercept a little bit, like a 1/4 inch of that flat on the side here, because the radius is so extreme here for the smaller part. It's really, the smaller part was challenging because it almost worked out that I was going to have to add some material on the side because the radius was almost smaller than the part extended out. And let's see, I grabbed the right one. No, I did not. That's the bigger one. So you can see the part itself is actually wider than the radius, the inside radius here. And so what I'm going to have to do is I'm going to have to cut some material out of the flats so that it can actually support the part. And it's going to be held way on the outside here. So that's going to be challenging in and of itself. Alrighty, so we're going to start on the small one first. That's this guy here. I've got a close-up. The front page is a scale drawing 1:1. This is a close-up. So I need to put these small flats on the sides and then a bigger flat on the bottom. So the big flat on the bottom is so the whole assembly can sit flat on a surface. And then the two on the sides are for the vertical pieces that will clamp on the parts itself. And they're very small. We're only taking 21 thousandths off a side. So what I intend to do is take a pass where I'm just barely skimming it, take a measurement with my mic, and then take off the rest, and then flip it over 180 and take the same thing. So you notice on my drawing, even though it's duplicate information, the measurement after I take off the first one, the first bit of material, will be 0.781, and then oh, I didn't do it. What I meant to do was to have what it is flat to flat space. Actually, I do have flat to flat spacing. That's down below on another one of these drawings right here. So 0.760. So that's pretty much it. Okay, so after the first pass, we've got a small flat here, and I know it's hard to see from your vantage point there, There's not a burr along the edge, so I can measure across here. One thing you tell that you've got the part in, parallel, is that the two lines on the edges of this cutout part are parallel. So if the edges of the cut, let's see if you can see this, if the edges of the cut did this or did this as an exaggeration rather than this, then you know that you don't have your part lying flat, because it's a cylinder and I'm cutting along a cylinder. We're shooting for 0.780, and it looks like we're about 2/10 over, but I'm going to buy that. First flat done. Second flat goes down against the parallel. Oops. Got to make sure to have some sticking out over the edge so that I can measure it. So I am pressing on the jaw asymmetrically. So back here, the jaw is going to squeeze in a little bit more than it is here because I don't have two of these parts. So that's a little bit of a problem. Ideally, you'd want this in the middle, but then measuring it would become a lot more challenging. I could just move the parallel off to one side and that probably would have worked. But I think we're going to go with this. It's not super critical. I don't know how well this shows up on camera, but second pass was a lot more parallel than the first, although it still doesn't appear to be perfect. It's kind of annoying because it is sitting flat. The parallel does not wiggle at all, is held nice in place. I moved things closer to the center of the jaw, so you can see here, so that there wouldn't be so much cant in the jaw. We're just gonna have to go with it. Alrighty, so we hit our dimension with a couple tenths over, which is completely fine. Accuracy is supposed to be like plus or minus 5 thousandths or something like that. So now I need to deburr this side. So we have two flats, which now I can do the vice jaws with the flats and do my top flat next. As you can see, this is not a lot of surface for the flat vertical pieces that are going to clamp on the parts to mate with. But it's the best I could do without significantly modifying the design. This part geometry is a little bit crazy. So I'm starting in about 40 thousandths of material what I took off on the other two sides. And since I have to take off a total of 154, I figure what the heck, we'll just start here. We'll go very slowly. So it's getting wide enough. There's a 1/2 inch end mill. We're going to do it in 2 passes. I'm doing climb cuts both directions. So you'll notice this is at an angle now. So the flats that I put on the sides, well, you'll never guess. They didn't sit on the vice jaws weren't actually sitting on the flats. They were actually sitting on the round. I didn't even notice. It felt like it was in there, but I didn't look visually. And then I noticed this time that it was a little weird. And guess what? It is a little weird. I might have just completely hosed myself. I might have to remake this part. So now we're shooting at the same depth we were at before. I don't know if I have enough material left to take off to make this flat again. The only saving grace is that I caught this while I still had about 52 thousandths left to come off. Last 20 thousandths. Oh, wonderful. It is not completely cleaning up. I think I'll be okay though. Okay, so the part will sit flat. There is my little screw up mark right on the edge here. And I'm going to call that a feature because that identifies one side, right? No, it's really a screw up. But it won't affect the functionality of this part, so that's good. So this piece sits flat. There's 2 vertical pieces that come over and clamp on the parts themselves with a stop on the end and a stop on this end. So we were going to move on next to the bigger part and just get it to dimension like this as well. So we're going very slowly. I've got it set for a 50 thousandths depth of cut. Slow the RPM down some. That was kind of high. It was at 1200 RPM. That'd probably be fine with coolant, but we're not doing it with coolant at the moment. To be honest, this is the kind of thing that would do really well bandsawing off the excess material to be faster. And I might just do that. I might get a flat on both sides, take it over the bandsaw and remove the bulk of the material. I thought more about the shortcut and realized that that won't work exactly, because I want my two flats, the one on top and the one that's going to be on bottom, to be symmetrical about the center of the curve. And if I cut these individually, they may not end up being symmetrical about the center. 50,000 step the cut passes. Pretty slow feed rate. So you can see what I mean here when I say that stainless is kind of gooey. You see how it turns up that edge? This is 303 stainless too. This is easy cutting stainless, easy machining, but still gummy. It's supposed to be 1.440. Looks like I overshot the mark. Dang it. 4.5 tenths. So when you take shortcuts, you can really get hosed. I know all too well. And so what I'm going to do to try and minimize that is give myself a reference line that's 1,000th over the point where I need to cut. I've got it to 0.953 here instead of 0.952. And I'm just going to scribe a line here so that when I go over to the bandsaw, I see where my cutoff point is. I think I need to put some blue Sharpie on here and do that again. In order to set this guy up in a bandsaw, I can't really have round part on the bottom. It's going to make it very hard to hold this thing vertically in the bandsaw in place. So what I think I'm going to do, since I want to remove material up to here as well, see this guy sits here, there's the first section off over here, or I could rotate it this way and there's the section off there, but it also needs to have the material removed this way. So what I'm going to do is I'm going to cut a flat below the center line, even though the final flat's above the center line. And then what I'm going to do is I'm going to take this back to the mill real quick, run a really quick pass over this to make this flat and square, and then I'll come back and bandsaw off that excess material. Okay, so I cut the bottom off after I cut the side, which gave me a flat to cut the side. I left a fair amount of material in case it wasn't perfectly square, and I cut the bottom just below center, which interestingly enough, the extra cut off waste pieces, I could actually get a whole nother piece out of this because this perfectly fits inside here. The bottom would just have to be like a couple thousandths undersized. If I'd gone right on center, then I could have gotten two good parts, but I didn't want to risk it. So these are my scraps that I cut off. This is my part. So I'm going to take and put this guy down and get this guy to final dimension. And then I'm going to come back and I'm going to flip this upside down, and holding the vice jaw between these two flats, which should auto-locate this time. Hopefully we won't have the same problem because they're so large. And make sure that the bottom is square and perpendicular to these two sides and nice and flat. All right, so we finished this side parallel to that side. Now we just need to do the bottom. Okay, so now we've got the two parallel sides in vice jaws, the curved side down, and we're just going to square this one up. Okay, there we are. Just got to deburr this guy, and the second one is done. All right, so next up, both the parts, I have to put slots in both ends. They're all going to be 400 thousandths wide, and they're going to be, one side's going to be 50 thousandths deep, and the other side is going to be 275 thousandths deep. First use for the leather that I've run across here is when I'm swapping end mills. In the past, I can't tell you how many times I've dropped an end mill and chipped the tooth on the end mill. I have ruined probably a dozen end mills that way, which is ridiculous. So I was putting foam under it, but that doesn't always fit. So I'm going to try this chunk of fairly thick leather that I was talking about in one of my quick tool reviews. I also, if you can see over here, I had some Naga Beast material on the back of this, but it melted when the hot chips hit it. The chips would stick into it. So the thinner leather I put on there and I oiled it, and it's wonderfully flexible. So I think that's going to work out great. Double check and make sure my vise is tight. Very good. All right. So those measurements are working out. We're going to flip it over and do the other side. The other side, we're just going for 25,000. I'm 50 thousandths depth. So I went 45 for my first pass. All right, so there's the two slots. Very beautiful finish. Really like this end mill. All right, so next part, same thing. Second part, slotting done. So all of the holes on this part, there are 6 holes that need to be drilled and tapped. So there's one on the end on each side, which I don't show on the drawing, but it goes this way, and then there's 2 on each of the flat sides. They're all spaced the same distance off of the bottom here. So there's the hole all the way through the part. That's pretty amazing. And so we need to drill and tap 2 on each side. So I'm going to drill all the way through the part laterally, and it'll actually meet up with this hole as well, because they're all in line with each other, because it didn't matter. I discovered I made my side dimensions kind of tight. This is going to be really close to the cutout here. It should clear, but it's not going to have a lot of extra space. Oh, and that'll be a problem because the screw's going to run into it. This one on this end, yeah, that's going to be a problem. One of the things I was trying to do was to make this part symmetrical about the center so I could flip it either way and not have to worry about it. But now I'm going to have to worry about it because it's now asymmetrical. Just because the screw going in the end here was going to run into this. If I had set that screw height at something different than I had chosen here, I wouldn't have that problem. That's what happens when you don't put everything on the drawing. I should have put the in-cut pieces. Mac, this one over here might be a problem too, just looking at it. Yeah, that one needs to go kind of deep, and this is not a very big distance. It's 100 and something thousandths. Yeah, I bet you I'm going to have to move this. I guess I can make it symmetrical. It's just going to be a lot tighter. There you go. I'm glad I looked at this. Well, unfortunately, these holes are going to be much closer together than I originally planned for. All because I centered those end holes, not thinking about the consequences, because I neglected to add part of it on the drawing that I should have, and then I wouldn't have gotten screwed. And that should complete this part. So it turns out if you can be stupid once, you can be stupid twice. So I made these collinear again. I'm just going to take the end holes and move them down. This is a much bigger part over here. So we're just going to move them down. So I got to get my zeros, and we're just going to do the same thing. Drill and tap, drill and tap. Hopefully drill all the way through. This one's thicker, but I think we can still do it. Here's this part done. Those are holes all the way through, tapped on both sides, drilled and tapped on the ends. And pressing up against the vise, put a mark on it. That's very annoying. I don't know if you can see that. Beautiful stainless got marked. Scotch-Brite might fix that. Next up, we're going to do the 2 end pieces. So they both have a hole on the bottom that is drilled and clearance hole on the bottom, and one of them has a drilled and tapped hole on the top for a set screw. These 2 pieces go on the ends here of the long bar, as you can see, to keep the parts in place. One of them you will loosen and flip to the side so you can load your parts, and then flip it back to weld. So we're going to trim these to length right now. They're rough length, and we're going to just use an end mill, get 2 sides to match, and then trim the other 2 sides to length. Perfect. And we're doing the next 2 the exact same way. So we're going to drill on the bottom, drill and tap just one of them on the top, using this as my 0 reference. In case you were wondering, here's the parallels I was using. The beauty of these is you can cut down the center of a fairly narrow part. Very handy to have and not terribly expensive. They're just spring steel, so they're hardened. They do tend to warp a little bit. These are inexpensive ones. Probably if you bought better ones, they wouldn't be as warped, but they work fine. All right, so next up we have to take these 2 bars, which are 2 parts each, and we have to grind them down. We have to remove 36 thousandths off the thickness of all but the last 50 thousandths of material. And this one And over here, we have to remove all but, we have to move 71 thousandths for everything but the last 50 thousandths over here. And then we got to set them an angle and try and grind that angle into them. So what I'm going to do is I'm going to grind them down square, and then I'm going to set them at the appropriate angle. This one's 35 degrees, this one's 54 degrees, and we're going to try and get these things right. So we're going to grind down the material all at once on both sides, and our goal is to go down the first 36 thousandths. I think there's definitely going to need coolant here. This material tends to burn really easily. All right, we've reached 36,000 depth. So there's the 36 thousandths depth. There you sort of see the edge. And we're going to put a slope on that next. But we've got to first take this down, the remaining part down 70 some thousandths, and continue there. Oh, you're an idiot. Left the magnet off. So to set the angle, we're going to use this angle adjusting magnetic transfer block, which is a really cool tool. Looks like you loosen both sides here, and then this guy slides. And we're going to shoot for 54. Which is quite a steep angle here. So I've used a parallel off the back to move this whole fixture forward. Probably didn't need it quite this far forward. I think I'll use a smaller parallel. And I've got the part sitting on the built-in stop on this magnetic block. Then I turn on the magnet and voila, it's incredibly tight. That's really pretty amazing. It could be a problem. I think my wheel height is going to be enough. Normally, I think I'd need this rotated 180, but I'd like to see the action if possible. The problem is this could run into the support column here. We're going to have to check that out first. Yeah, I think the angle's going to be too much to make it. So it doesn't make it. So I've got to flip it 180, which means it's going to be very hard to see while I'm doing it. All right, so I don't know if you can see this, but apparently the bottom of that part, the fence on this is not perfectly square, so I had to shim it a few thousandths to get the part to lie flat and get it to equally take material off the whole thing. This is the second one at 35 millimeters. And I had to shim the end of it because it wasn't sitting flat, but I got it to cut fairly evenly across. All right, so we surface ground both these parts. Now we need to cut them in half and cut them to length, and then we need to put slots in them, as you can see here. Following the same process as before, just trimming these to length. So run an end mill over one side, clean it up, flip it around, and then we'll measure and walk it in. Okay, so I'm using an 1/8 inch collet, and I'm going to use an 1/8 inch end mill. So if we're going to start with an 1/8 inch drill bit and pre-drill the center holes for these guys that's undersized, that's 0.125 and we need 0.144, so we got plenty of upside. So we should be able to get a nice clean slot out of it. That's a 1, and go 0.288 the other side. These are kind of close together because of my screw up earlier. Now we're going to switch over to an end mill and we're going to cut some slots. Actually, I think I'll switch parts because I've got everything centered up perfectly, so it should work out very easily. I can swap parts and then just do one after the other. So my stop here, I went up against it very lightly. And we're going to drill the same 2 holes. Now I can switch to the end mill and we're going to slot these with the end mill. So I've got the RPM way up. These end mills are Chinese end mills, and they are not the best. So at a really high RPM, well, 2,500 or so, you got to take little bites. Okay, now I need to go over 10 thousandths, and then cut back up. Here's a 632 screw, Nice fit all the way around. Perfect. So I'm just going to duplicate that 4 more times on all the other parts, and I'll bring you right back. Surprise, surprise, the parts are nowhere near as accurate to the drawings as they said they'd be. They're stamped parts, but they had pretty tight tolerances, but they're not meeting them. So I'm having to relieve a little material to make these work right, because the parts won't fit. All right, so here are the parts. I didn't show the assembly because there's not a lot to it, just a few screws. There's a lot of dialing in to do and adjustment because these parts are stamped, and so that gives them burrs and some variation in size, and it makes them very difficult to slide smoothly along lengths. So it was quite challenging, to be honest with you, and that's it. I learned a ton on this project. It was extremely challenging for me, a bit outside my wheelhouse, so that's always good. Thanks for watching. Hope you find it useful. Hope to see you next time. Please comment below.